The connecting rod is the link that transmits forces between the piston and the crankshaft. Connecting rods must be strong enough to remain rigid under load, and yet be light enough to reduce the inertia forces that are produced when the rod and piston stop, change direction, and start again at the end of each stroke. There are 4 types of connecting rod assemblies: plain, fork and blade, master and articulated, and split type. The master and articulated rod assembly is commonly used in radial engines. In a radial engine, the piston in one cylinder in each row is connected to the crankshaft by a master rod. All other pistons in the row are connected to the master rod by articulated rods. In an 18-cylinder engine, which has 2 rows of cylinders, there are 2 master rods and 16 articulated rods. The articulated rods are constructed of forged steel alloy in either the I or H shape, denoting the cross-sectional shape. Bronze bushings are pressed into the bores in each end of the articulated rod to provide knuckle pin and piston pin bearings. The master rod serves as the connecting link between the piston pin and the crank pin. The crank pin end, or the big end, contains the crank pin or master rod bearing. Flanges around the big end provide for the attachment of the articulated rods. The articulated rods are attached to the master rod by knuckle pins, which are pressed into holes in the master rod flanges during assembly. A plain bearing, usually called a piston pin bushing, is installed in the piston end of the master rod to receive the piston pin. When a crankshaft of the split spline or split clamp type is employed, a one-piece master rod is used. The master and articulated rods are assembled and then installed on the crank pin. The crankshaft sections are then joined together. In engines that use the one-piece type of crankshaft, the big end of the master rod is split, as is the master rod bearing. The main part of the master rod is installed on the crank pin. Then the bearing cap is set in place and bolted to the master rod. The centers of the knuckle pins do not coincide with the center of the crank pin. So, while the crank pin center describes a true circle for each revolution of the crankshaft, the centers of the knuckle pins describe an elliptical path. The elliptical paths are symmetrical about a center line through the master rod cylinder. It can be seen that the major diameters of the ellipses are not the same. Thus, the link rods have varying degrees of angularity relative to the center of the crank throw. Because of the varying angularity of the link rods and the elliptical motion of the knuckle pins, all pistons do not move an equal amount in each cylinder for a given number of degrees of crank throw movement. This variation in piston position between cylinders can have considerable effect on engine operation. To minimize the effect of these factors on valve and ignition timing, the knuckle pin holes in the master rod flange are not equidistant from the center of the crank pin, thereby offsetting to an extent the effect of the link rod angularity. Another method of minimizing the adverse effects on engine operation is to use a compensated magneto. In this magneto, the breaker cam has a number of lobes equal to the number of cylinders on the engine. To compensate for the variation in piston position due to link rod angularity, the breaker cam lobes are ground with uneven spacing. This allows the breaker contacts to open when the piston is in the correct firing position. Knuckle pins are of solid construction except for the oil passages drilled in the pins, which lubricate the knuckle pin bushings. These pins may be installed by pressing into holes in the master rod flanges so that they are prevented from turning in the master rod. Knuckle pins may also be installed with a loose fit so that they can turn in the master rod flange holes and also turn in the articulating rod bushings. These are called full-floating knuckle pins. In either type of installation, a lock plate on each side retains the knuckle pin and prevents a lateral movement.